Is it just me?
On YouTube streaming?
Yes.
Yeah. It says I don't have access for streaming or something like that.
Yeah, same. It shows we are live.
If you're going, showing, waiting for cloud and coffee with Navnit. What is wrong? Even StreamYard. One more waiting. Showing we are live. You are live. View on YouTube. Perfect, perfect. We are live on YouTube.
All right.
Are we? I still see waiting for cloud and coffee to start.
Okay, so let me paste here. So okay, you guys able to see, right? So we are here. Hopefully things works fine.
Yeah.
So let me post on LinkedIn so people are aware. Let me post on the event page.
Yeah. I can see it live on YouTube.
Just it. Okay, cool. So we're all set. We are going to get started. Everything is working as expected. So okay,
I
I
see Abhishek though.
okay. Let
Yeah,
me.
again, yeah. I
Okay,
can
you guys,
just
you able to hear me now, Abhishek? You're here.
yes,
Okay.
yes.
So my apologies to everyone. We were testing our different platform, and happened to be one of the platform was not working on time. So we are back with yet another session. So hello everyone, this is Navnit, and welcome to Copy and Cloud with Navnit. And today we have very special guest. One is who's joining from India, and it's happened to be a Friday night, and he was supposed to go on a party, but yet he are here doing and helping broader community to learn how to save a cost on a cloud. So I will let introduce our first guest, Abhishek. Over to you.
Hi, everybody. So I head engineering at an academy, and we will be talking a lot about the cost reduction, etc., optimization. But on the personal front, I do a lot around traveling. I have done a couple of solo travels, and similarly, I've been learning music and trying out music to a great extent. I see a guitar right
Yeah, no, it's just for showcase. I don't know
now.
how to play it. So I should look cool, right? So let me move to our next guest, Kiran. Kiran, he is a colleague of mine. I've been working with Kiran on a lot of big data optimization over the year of time, and I thought like, okay, having him, and especially we are on a data space where everyone is talking about data. So I thought like having him and share his perspective will be nice. Kiran, over to you. Please introduce yourself to our audience.
First of all, thank you very much, Navnit, for inviting me on your podcast. And hello, everyone. My name is Kiran Godaguntla, and I've been at AWS, helping customers optimizing their journey through cloud and optimizing their costs by migration and modernization. And I live in hot and toasty Dallas, and of course, I know I am also dabbling in music, Navneet, like you. But I start, hit a plateau, and leave. Uh, I need to find time to practice, but music takes a lot of time to practice. And
Yeah.
I have two boys, 15 and 11. They play piano, and now one of them is playing flute. So I enjoy them, listening to them and see them grow in their musical journey.
Good
But
to
yeah,
hear. Good to hear both of you. So again, I think did I introduce myself? Oh, no, right?
no, not yet.
Yeah.
Okay, so I'm the host here, and I just started this podcast. And the whole idea about this podcast is to have a people like Kiran and Abhishek come to and join it. So we should not be we are not looking to have a what we call it, like we wanted to have a real life celebrities, and especially people on the technology front who things make happen, right? We usually celebrate people who are front, and who are being kind of more celebrated than the people who actually are on the background, who actually make these things happen. So yeah, and then of course talk about all things about cloud, and our personal journey around in technology. So let me start with our first question, and this will goes to both of you, and then I will we can move to the other section. So like every podcast I've been doing, so we're going into different sections, and we already done the introduction, so we will be moving and learning around. The first section will be around the cloud scalability and cost effectiveness, and why it is important is especially when the cloud was started back then, right, almost like 12-15 years back. The whole concept was this is being adopted by the enterprise. So the whole idea is how we can able to go into different market super fast, how we able to scale. But eventually when those startups become enterprises, or even when they start maturing into their journey, uh, the one thing definitely being is cost, especially in this economy. Like, hey, how we able to help reduce cost? So Abhishek, I will ask you to define, like, what's the cost efficiency for you mean, right? Because you have a background of startups, Kiran
Yeah.
helping and supporting enterprises and all other kind of companies. So help me understand what's the cost efficiency when we talk around startup, when we talk around enterprises, when we talk around ISVs, which if you not know, ISV is independent software vendors, right? So help me understand what's the cost efficiency is.
Yeah, so if I were to term it right in a single word, right, what a cost efficiency is, it's all about, maximizing value for each and every dollar that you spend, at the same time maintaining the performance, scalability, and the security for your application that you require, right? So basically optimizing for, whatever you are spending on, correct? And see, any startup for that matter, or any of the enterprises, right, are majorly built out of the business model, right? They are all here to do business, and at the end of the day, it boils down to, are you making right ROI of it or not? And when you reduce down, when you are making, maximum use of the every dollar that you spend, basically you are optimizing on the profits for the company and reduce it down your bottom line, right? To great extent, right? Fundamentally, I believe, that's where it lies.
Mhm.
Perfect. Over to you, Kiran.
No, so first of all, thank you, Abhishek. So that was a great point, right? So, but in addition to that, what I would say is that when it comes to cost, there are multiple types, right? So there are, first of all, operational costs, of cost of running an environment to run certain applications, right? Those are tangible costs, right? So costs that you can see and experience and pay, right? But there are a lot of intangible costs, like in terms of administration cost, a lot of costs incurred due to downtime, right? And then also, most importantly, there are certain ideas that you, as an enterprise, that you will come to, that your teams will think to, and then you want to go to market with it, right? In a traditional way of doing business, taking that idea, testing it out, and then going to market can be a lengthy process, because to get the infrastructure required to test it out can be a lengthy process. Whereas in cloud, you can do that much, much faster, because it's a matter of like clicking a few buttons to get an infrastructure set up. So going to market faster and realizing the value of it faster is, in my opinion, a big benefit of coming to cloud, right? Whereas you were not able to do that in a traditional environment, that lost revenue should also count towards cost of doing business for you, right? So I think enterprises look into that aspect as well.
Yeah. Before we can move into the our section here, so yesterday I was scrolling over LinkedIn. It seems like that's my part time job now. I'm going and scrolling over LinkedIn, but I was reading one post. I don't know it was even real or not, but someone said, "Hey, I'm a student. All of a sudden, I got $40,000 cloud bill." So first of all, like great powers comes with a great responsibility. Cloud bring you like all the resources on a click of button. So you should be very
Yeah.
uh, kind of you should be using it wisely, right? Because you or end up having too much of cost. But anyone having such an issue, if you run out of yeah, having such a big budget, you're a student and you all of a sudden you will be having like 40K US dollar of your bill to reach out to AWS, and they might able to help you with there. So, and again, are we going to talk about like, okay, what kind of measures you're able to put a control on a cost? But let's move to the scalability and the cost effectiveness. Abhishek, the question to you, as right, you were working on the startup world, where the scalability he wanted to who wanted to expand really fast. So help me understand what's the balance between the scalability and cost effectiveness. How you able to manage, or are there any challenge between scalability and cost effectiveness?
Yeah, definitely. So, if I'll talk about the experience, right? In general, like, any startup goes through a phase of, hyper growth phase, then they plateau, and sometimes, they also go through a downfall as well, right? Given the recent markets, we know, right, how the market has dried up as well, right? So, it all depends on what phase you are in during your startup, right? When you're in hyper growth phase, what happens is you're very much focused on the scalability part of it, and that's where you also tend to miss on focusing on the cost aspects of it, right? Though engineers and individuals would be aware of it might cost us heavy, etc., but then that's the bet that you take, right? It's a trade-off that you're making, right? Now talking about scaling at the time of, let's say, when you have constraints, like talking about the current scenarios where the markets are dried up, etc., where you want to build up the balance between it, right? The Some of the challenges majorly what we face is you know they would be uncertain spikes in demand, right? So for example, if we are preparing for some of the events, let's say in e-commerce, a common event would be hyper sale events that are happening. So the major challenges that usually we face is or the methodologies that people use is the pre-scale infra, right? And rescaling has its own cost to it, right? And another challenge that usually we face is let's say you are doing the right auto scaling, etc., but then when you see a peak or hyper peak in demands, the time for infra to spin up usually introduces latencies, right? So there needs to be a complete trade-off between what you usually want to spend in terms of the cost versus the availability of the system, right?
Hmm.
That's a
Yeah,
good, really good, like having the cost that you do not want to get into the trap, right? Where hey, we wanted to have this being scaled, like or hyper
yeah,
scale, without being worrying about the cost, because or without keeping the cost in mind, because eventually then it will be a backward journey where now you'll be
yeah.
optimizing for cost and then compromising for the scalability. So Kiran, as your experience with AWS, right, how do you advise customer to ensure they able to scale, they able to achieve what they're looking to have without breaking the bank? Like
Right.
what's the recommendation you will have?
So, when it comes to the cloud architecture or management, right? So it's all about implementing best practices. Like you said, Navneet, that you read a post. In fact, I encountered the same thing, that you spin up a cloud environment, give your credit card, and then And if you did not set up your guardrails correctly, and you can rack up costs, right? So setting up the guardrails correctly, and many of the cloud vendors give guardrails, like setting up the budgetary controls or
Budget.
compute controls. Setting Understanding what the guardrails are and setting those up are very important to arrest those runaway costs, right? Now, when we're talking about scaling, yes, cloud provides great flexibility in terms of scaling up the resources. But if you don't architect it right, you can scale up and stay there, right? So, and when the demand dies down, you have to architect your application such a way that the resources will come down when your demand is not so high for computing resources, right? That is one thing. Now we are talking about compute, but are also the storage, right? So as enterprises grow, you will acquire data from many data sources, and the data starts piling up in your whether, let's say, S3 or, like, cloud object storage. Now you have to be intelligent enough to dig through the data and see what is important for you, what is live, and then use some of the intelligent tiering that cloud infrastructure providers provide to take advantage of that, to move data into some of the less expensive tiers to save some costs, right? So all these come under these guardrails. So you need to take advantage of what cloud providers, the features that cloud providers provide, and architect your applications correctly to not fall into that cost traps.
Yeah, I think the one important aspect which I see usually people miss is on the cloud spaces around the knowledge, right? Because clouds move really fast, the innovation moves really fast, regardless the cloud provider, whether it's AWS, Azure, Google. And they'll always they come up with the best practices to use it. And you rightly mentioned around the S3 intelligent tiering. It's a no-brainer. Hey, if you are building your data lake solutions on AWS and you've been having a lot of data, you do not know what's the access pattern look like for you to go and work on the data. You're able to go and enable the S3 intelligent tiering. Then it will be analyzing your access pattern, and allow you to retrieve the job allow you to retrieve your data from your data lakes. So that is again this is one trap, right? Without even knowing, okay, not having yourself updated around it, like, okay, what's going on in the cloud world, how you're able to put all kind of guardrail there. So that's a good segue you have mentioned around when you will be architecting your solution, what kind of a guardrails you're putting within your architecture. You rightly mentioned, Kiran, right? Okay, you've been, if you just architected for your peak, and if you stayed there, and if your
Yeah.
demand dried down, then it's going to be super difficult, and you will be end up having too much. So that's kind of a good segue to move to our second section, is more around the architecture. So Abhishek, we have been hearing this serverless event driven architecture, all these good words. Help me understand how this event driven serverless architecture to help you to reduce cost, or what all should you keep in mind when you will be architecting your solution in general?
Uh, so so I'll start with, right, when we talk about serverless, it majorly or serverless or event-driven architecture, it majorly comes from the idea of microservices, right? So basically, there are multiple components, multiple services who are talking to each other in the form of pub sub, right? You're sending messages, and through the events, basically these are communicating. Now the power that we get with it, right, is that you can scale individual components basis the need. And basically you can also balance between some of the computing systems which are maybe who need or which one need basically real time processing and computes versus something that can be done in the background. Now when you do it in the background, you can balance out how much compute or how much resources you want to give, and basically you are trading off between the time frame, right, of the processing. So one such example I would like to add is, let's say you have, maybe let's talk about, like, let's say it's a Netflix, right? And Netflix would be doing a lot of processing in the background with respect to the video encoding, decoding, etc., right? Uh, Now, and they would be generating multiple resolution, and for that matter, YouTube would be doing the same, right? Now, you need not put up all the resources or all the compute in real time because people can wait, right? Your tat to make that video available can be 3 hours or 4 hours, and that is where you can balance the compute in the processing which can be done in background, right? However, something in real time which is needed is where you can balance out, and that's where when we talk about event driven architecture, when you have multiple services and multiple components, what can happen is the components which really need scale can be scaled independently, and that is where it helps us optimize the cost where it is needed, right? And you can spend where it is needed, right? And another point I wanted to bring in was like the power of AWS like SQS and SNS, which we actively use in event driven. One of the best thing is it is more on a pay as you go model. So as many messages that you send and consume is what you're paying for, right? And that's the best part, right?
Help me
When we
understand if someone is new to an AWS, was this SQS and what's this SNS, and how this play a role in that event-driven architecture?
Yeah, all right. So, when we talk about event-driven architecture, what we are mainly talking about is, there's one service which is communicating with another service in the form of a synchronous way, which is, the service one would be publishing some events. Okay, I want maybe the video to be processed, or you create, three different resolutions of this particular video. Now, the service one has just communicated to it, right? And then service two bases the resources available, right, would be consuming from this queue. Now I'll talk about what is SNS and SQS, right? So SNS is basically a notification service which service one would be using and coming and sending to the SNS mentioning that publish this particular message. Now SNS needs to know where does it needs to publish, right? So there can be multiple subscribers to it, right? And that is where a queue SQS is basically a queue system, right? uh, which basically subscribes to this SNS and the message is being sent to it. And then there would be a consumer service, right? And which can scale basis the queue length. That is the general pattern that we use for auto scaling. And you can always define, let's say your tats are defined as like 3 hours, 4 hour of the processing. And like, on an average, a single message processing might take like 1 hour. And you can cover up, if the number of messages are X, then increase the workloads or your workers by Y, right? And that is how the overall system integrates, wherein system one communicates with the system two, but in an asynchronous way. Now,
Okay.
there's another piece that I want to bring in here, which usually helps with the fault tolerance of your system, and which is basically ensuring you have the dead letter queues, right? So when the system two is consuming something, and let's say there's some error to it, they can always push back these messages to dead letter queue, and that's where basically you always know what are the messages were missed, and if you want to reprocess because of the once you fix the bug, you can do that, right?
Perfect. Perfect. Yeah. So I will ask you one more question, but before let me go to the Kiran first. So Kiran, what Abhishek is talking around, it's more like a lot of engineering work for sure, right? And definitely you need to have a good engineering team. What we have seen here within enterprises, they've been running this legacy system where they will be doing this horizontal scaling so long, everything's run into a single monolithic cluster or database, etc. What's the shift look like for them? Because hey, they can't just bring everything and just make into the microservices or even driven architecture, what Abhishek was talking. So if they have to move to AWS cloud, right, or they have to move to cloud in general, uh,
What is the
what's the recommendation for them, like how they should be moving?
right? So I can talk from the analytics applications perspective, right?
Mhm.
So in a traditional on-premises or like a self-managed environment, the fundamental architecture pattern is a tightly coupled storage and architecture, right? And that limits scaling, right? Both horizontal and vertical scaling. But when it comes to cloud, the architecture pattern is separation of compute and storage, where you put all of your data into an object store, and then move your compute into any of the services that work best for you. For, let's say, Spark processing or ETL workloads or data warehousing workloads, and all of that can be separate from the storage. So that is the first step of the flexibility that you get, right? Now, what that does is that you don't have to have a infrastructure or a cluster running all the time for all type of applications. Now, you can split your compute into multiple infrastructures or clusters that are specifically suitable for that particular application. For example, if you need a interactive type of applications where users are hitting it all the time, you can have a cluster sized for that particular use case and dedicated for that. Or let's say if you have a batch job that runs at a particular time in the night. For example, you need that job to start when an event happens. You can design your pipeline such that when that event happens, you can create a cluster, run that job for how many hours, and then reclaim the resources or terminate the cluster, so that you can guarantee to pay only for that amount of resources that you are consuming for that particular time, right? And then Abhishek mentioned serverless. You can also go for serverless to kick off the job on a serverless application, run the job, and then let the cloud provider take care of spinning up the resources required and all of that.
So what's the? I'm so sorry to interrupt you. Don't want to break your thought here, but because we have been talking about serverless. Help me understand what the serverless is all about.
Right. Yeah, it's a good question. So the difference between a server full or a cluster full application and the serverless application is, with cluster full, even on cloud, the user or the customer is expected to spin up a cluster, meaning instances or VM instances, install the software and then responsible for administering that cluster. But with serverless, there is absolutely no infrastructure or cluster for the customer to manage. You customer can simply submit a job, and the cloud provider takes care of spinning up the resources, running the job, and terminating the or reclaiming the resources that are required. So it eliminates the any administration overhead if you use serverless applications. So that is the fundamental difference. And also, second difference is the way we bill and the customer get billed for the resources. In a cluster full implementation, you get billed for the instances and the instance hours, how many hours that you run that cluster for, whether you are running something on it or not. But on a serverless application, you will get billed only for compute resources that you are consuming. So there is no inefficiency there. So you are guaranteed to pay only for the CPU and memory that you are consuming for those applications. So that is some of the key differences between the two.
Got it. So
Uh,
yeah,
Yeah,
if
just
you have something to add.
just want to add one point here. Like this is something, which I commonly observed as a pattern. Many times what happens is individual try to, think that serverless would get, only being charged for what they are being consuming, and many times they make a wrong choice of, using it in an application which needs most of the time, into computation,
Yeah.
right? And that's where I think it's a wrong choice. Usually, I think serverless should be used in the places where you feel during the day, like maybe only 2 to 3 hours or 4 hours. There's a specific time frame where you need the compute. Rest of the time you don't need it. Would be a better choice, right? Rather than, let's say, if your workloads are running 24/7, right? Making serverless choices there is usually, I found it to be more expensive, specifically with the usage of Lambda, right?
Perfect, perfect. So the crux of this, I think, that if we conclude our first section, is definitely you should be making the best architectural decision based on where you are currently. So you've been starting from scratch, maybe the event driven architecture or microservices architecture best. If you are going into, if you're already running the monolithic cluster, more like the what Kiran has suggested, breaking down into small pieces and use, like, okay, you don't need to be have one databases to run all your applications. You can have a multiple databases, and you can, if you need, if your application require 24 into 7 processing, maybe going with the server full architecture will be helpful. However, if you have a or if you have engineering resources in very first place itself, right, the total cost of ownership, or if you're just running your workload for very specific set of hour, maybe going into the serverless architecture will be helpful, because you will only paying what you will be using. You will not getting paid for resources. So that's a good segue for us to move to our next section, that is data processing and modernization. So objective of this session is like how you able to use cloud for the data processing, because I think that's the one thing which is being asked and being done by many customers, and not with the Gen AI expert, right? You have to have a data processing being done in a right way. So Kiran, so you help a lot of organizations around there to modernize their data platform, and we have personal connections there, like where we have worked together. So help me understand what's the biggest challenges in reducing the cost during the large scale migration. I'm talking around the data in maybe multi terabyte or multi petabyte of those migration, and
Right.
especially when you bring the data, how you able to, how you able to process the data in more like cost effective manners.
Right. Okay. So this is my sweet spot. This is where I spend a lot of my time in helping customers with, right? So the challenge with the legacy applications is their legacy. Okay, that customers have built these applications over long periods of time, and they, like I mentioned earlier, they have been getting data, persisting that data in their monolithic cluster for a long time. I know. And then in addition to that, they have been writing applications, customizing their code for last 5, 6, 10 years. And in many cases, they don't have proper documentation in those applications. And then people who have wrote those people who have developed those applications have left those organizations, and they don't have any knowledge around those how those applications run. Now, when they want to modernize those applications into cloud, the big challenge is these legacy applications. They have been running on very old versions of their choice of framework, right? And when it comes to cloud, what is can they upgrade? And when they upgrade, they would have to, sometimes they may have to rewrite some of those applications, and customers are apprehensive in touching those applications, or whether their legacy applications will run, what will break, right, when they upgrade to the latest versions. And if they don't use the latest versions, what cloud has to offer, then they are not taking advantage of the best performance that the latest frameworks can provide, right? So that is one trap. Uh, and the second trap is if they choose to use the same old versions of applications, wh- at some point that will break, right? So when they choose to, whether they take the leap now to upgrade, or they lift and shift whatever they have into cloud first, and then upgrade later, is a architecture decision that we work with the customer and help them make the right decision. And the second trap that we see is the data piece, right? So customers have accumulated a lot of data, and some of that, lot of that, in my experience, is cold data, right? That they don't use anymore, or not valuable, right? But sifting through that and then determining what is really useful data and then what is not, that can be pretty much, let's say, archived, is an exercise that customers have to do. Like, really looking deeper into their data sets and see what is really valuable and not. Otherwise, you will end up processing that data over and over again, right? So spending some time and then sifting that data through, moving archive data into, let's say, Glacier, for example, and then moving to active data that they will need to analyze that actively into, let's say, standard layers of object storage, is important, right? So legacy applications and legacy data are some of the things that usually that rakes up costs.
So you talked around most around that storage cost. What about the processing cost of the
Yeah.
data?
Exactly. So the more amount of data that you have to process, that's where compute costs rake up, right? So understanding what is the most important data set that you need to process, right? That is what results in the compute costs.
No, in terms of like it, let's say if I have I brought my data in. I know need not to process the entire data set, but if I have to process even petabyte of data or terabyte of data, what kind of a good compute choices I can make
Yes.
right, to process the data. Like, I know you've been work a lot around the spot instances. Just help
Instances.
me understand what those are and how they will be being used
Yeah.
here.
So when it comes to compute, right? So first thing is the compute choice, right? So in a legacy environment, you will have typically have one instance type with certain CPU and memory, and all applications that are running on that cluster will use the same instance type. But with cloud, you will have the flexibility of splitting it into multiple clusters, but also pick the right instance type, right? So whether it is a memory intensive incentive application or a compute incentive application, picking the right instance type is important in optimizing your compute capacity. That is one thing. Second thing is using the latest instance type. For example, with AWS, we release latest instance types every year, like Graviton, for example. Like right now we are at the third generation. Using staying in the know of what are the instance types that we are releasing, and picking the right instance types is important in optimizing the cost and reducing your runtimes for your applications. Second thing, what you mentioned, right? So cloud providers, for example, AWS gives options for reserved instances or savings plans. And then the best part is the spot instances, which are about 90% less expensive compared to on-demand instances. So ability to tap into the spot market, architecting your applications to take advantage of those spot instances is very important in optimizing your compute costs.
Perfect, perfect. Make perfect sense. So, Abhishek, as someone you deeply involved on like platform reliability, right, and you have been helping helping your organization to reduce costs. So help me understand, right, when you do a microservice architecture, how it has like how it work with the modern data systems. Also, help me understand the importance of continuous monitoring your application in order for you to get cost saving. How that can be done.
Yeah, yeah, sure. So, basically, cost efficiency is at the heart of, when you're doing the microservice architecture, right? The reason why you are doing it is to also make your teams efficient, right? It is also a representation of your organizational structure, right? Independently, teams can work, and shift very fast, right? And why are we doing it is also to make our teams and, our releases very efficient, right? So the whole purpose of moving to microservice architecture, I personally believe comes from the single fact of ensuring we have the right cost efficiency and overall efficiency of the deliveries of the system, right? Now when we talk about cost efficiency in microservice architecture for modern data systems, uh, I I believe the way to approach is to basically decoupling for scalability, right? So in data systems, the microservices allow us to break down complex processes. This could be, the ETLs, real-time processing, or the analytics into smaller and independent unit, which can scale independently. Now, by decoupling these components, basically we are avoiding scaling the entire system when only one part of the process requires more resources, ensuring we have like the granular level and the cost-effective scaling in the parts where it is needed, right? In some of the cases, maybe your analytics could be very compute extensive. In some of the cases, the real-time processing would be would need more resources. So basically, while designing these data systems, the one of the way to approach is to basically decouple for the scalability. Now, the second bit to it would be, right sizing the storage and the compute. So with data, one of the main challenge is basically balancing between the storage cost and also your processing efficiency. So by using like cost efficient storage options, something like, S3 for data lakes, as Kiran was also mentioning, right? You can put up whatever is being processed or already compute for your data lakes maybe in the cheaper storage like S3, and only moving something which is compute expensive and which is only when necessary you can move it to compute expensive resources like Redshift or the EMR clusters, right? And with using this approach, basically you can reduce down on the cost, right?
So
Yeah.
usually what happened is, right, when customer reach out to me, and again there's a very delicate balance between your concurrency requirement, your latency requirement, and then
Mhm.
of course your cost. Okay, because you can't be have highly you can't be have very low latency system built with a lower cost, because you have to have
Correct.
data process in the memory. And again, right, cost efficiency does not mean is reducing the cost all the time. Cost efficiency
Yes.
also mean is like what you've been using for what purposes. So if you do not need to have a data latency requirement of millisecond latency, and if you put that into some kind of memcached, then eventually you
Yeah.
will be exploding your cost. That's where you will be like,
Correct.
making those balances is super super important, and knowing your customer how they able to using the data. So when you will looking to choose between your storage system or your compute system, these are the three things that usually I ask my customer to know from their business. Hey, how was the latency requirement look like? Was the
Mhm.
concurrency requirement look like? How many people concurrency, when we say like how many people going to
Yeah.
access your system a single point of time? Latency, how soon you need a result? And the third one is how much data you're looking to scan. Maybe
Yeah.
if
Yeah.
you're building a web application, you are not looking to scan the entire repository of your data. You will be looking to see like limited amount of data. Whereas when you will be building some kind of a trend forecasting, or where you will be building some kind of a reporting, you may be going and scanning the entire data set, right? So these are the three factors. So, and again, that help us to move to our next section, is the future of the cost optimization. And when I said like, we are, when we say cost optimization, is not like, okay, you will be dying down, like you will be shutting down everything and then, right, entire business, that will reduce your cost. It's more like making the right choices. Now guys, help me understand, now we've been into gen AI era, right, where, and those models are not in kind of cheap models, like, okay, you definitely required to process a lot and lot of data. So help me understand, if some organization that I've been hearing from customer, hey, we wanted to spend more on the gen AI, then we have to reduce on other costs on the other. So if you're moving towards the journey in the gen AI era, what will be your recommendation around the cost, or what's the future of the cost saving look like in the Gen AI era, if I have to say?
I
Kiran.
can probably take a shot at it. I think, Navneet, it is still evolving, to be honest with you, right? So one thing I would definitely say is, especially for enterprises, and these, I'm still talking about the analytics applications that process terabytes and petabytes of data, right? And the main cost savings or cost optimization effort there is improving the efficiency of their applications. And how they can do this is, for example, they can use Gen AI to parse the data in advance, right? And scale their resources, or getting the recommendations first, right? So understanding their data sets first, and when they persist the data or store the data in S3, the optimum way to persist data is one way to optimize cost. And then code development also, now we have autopilots, right? Things like that that can help you write efficient code for processing the data, and that eventually should reduce the compute capacity required for running your applications, right? And so things like that. And let's say in the past, whatever applications that customers have written to parse or process some of the data could be probably easily done by some of these large language models more efficiently and more easily, right? Uh, to me, at this point, getting the recommendations in time to speed up this computing, getting recommendations to optimize your data processing applications, and then getting recommendations for passing the data or data in advance are some of the things that they can do to optimize costs. But again, I think this is in the beginning of the journey. We'll get to know more as more and more applications get built with help from Gen AI
Yeah,
capabilities.
of course. Yeah, Abhishek, what was your take here? I know it's a little
Yes.
googly.
Yeah, it is. Yeah, as Kiran rightly mentioned, right, we are in the very early stage of, Gen AI being progressing, and every other day we see, there's a new progression that is being done, and which is something, unexpected, right, to a great extent. So if I were to talk about how I see, Gen AI contributing towards cloud cost optimizations, majorly, one of the key thing that I see is with respect to the predictions that we can do, right, with the data which is being available, right. You can have better recommendations, and also there's a lot of, like, AWS provides it, right, has been providing recently, the recommendations on, how you can optimize cost. And this also talks about, the underutilization and the over provisioning of the resources, right. So that is just one angle to it, but however, you can, forecast how the cost would look like, and basis those forecasts, basically you can also plan your business. So for example, XYZ months are my, high revenue months, let's say. And this is the production basis, my current business, this is the infra cost that I'm incurring, right. And I can plan, right, during my high revenue months, how I can, use this data to plan for, better business unit economics, right. So I personally believe mm, Gen AI is more and more, making us more productive, right, or basically, helping us get things faster done, right, compared to the time that we used to take before. Now making these prediction, etc., really helps to improve the business in turn as well, right.
Makes sense. Makes sense. Usually, you know, me and host, I should not be kind of enforcing on telling my, but again, I'm a technologist as well. So what usually when I go and talk to customer about, hey, we wanted to build this Gen AI application, and we are definitely, there's always a, we wanted to do a uh, optimization there, right? So this will be, because this is again new and evolving. You want to do a lot of POCs and everything as such. You want to test out how even before you going, and then it required cost. So I usually go and say, hey guys, when you will be doing it, even your existing environment is being optimized for the cost, right? Wait, before you can go and go there. One of things which I like, I start with the very basics, like, hey, you've been using this system from so long. Do you guys have a reserve instance? If you not know the reserve instance, is more like, hey, you able to buy those in a much more cost effective manner from AWS, but with some kind of commitment, whether it's a 1 year 3 year commitment, right? So that can be done. Other is like, okay, when you've been running your system, how you've been running your system, whether you will be using the spot instances, you're not being using the spot instances, etc. And more importantly, which I see here is, now you have, for using the Gen AI, you have not to move between the multiple systems. You have a multiple system in very first place itself. So you can get like where your data is, and then start using your Gen AI, and you can start your Gen AI journey there. So this way the data movement will be super less, and you will be not spending too much money around moving the data and processing the data for your Gen AI, right? So that's the thing. So we will be, I think we are our end of an hour, and we started late. I know, Kiran, you have to go. So Kiran, help me, understand, if I am starting my cloud,
Journey.
like the title of our podcast is like, cut the cloud bill. If I'm starting my journey there, what are the three things I should be keeping in mind, and I will be working on my cost reduction project?
Right. So first thing is getting the architecture right. Taking the right architectural decisions at the beginning, right? So about the decisions I talked about, like separation of compute and storage, and within the compute, identify opportunities to split the workloads into, service specific or application specific environments, whether it is clusterful or serverless applications. Taking those decisions and picking the right frameworks that you want to use to process your data, right? So picking the right frameworks is important to get the best performance, which will result in less compute and less cost, right? That is most important. And architecture in applications in such a way that to take advantage of all the best things that cloud has to offer in terms of reserved instances or spot instances, things like that, that can help you optimize costs.
It's
To me,
really,
these are fundamental aspects, and then there are many others in terms of optimizing further.
of course, yeah, fair enough. Abhishek, to you.
Yeah, so as Kiran rightly mentioned, like having the right architecture is very, very important. Also, diving deep into the principal key component, something like monitoring your compute correctly, monitoring your network data in and out, right? Also monitoring your storage is really, really important. Another angle to it would be setting up right guardrails, right? Which is basically setting right budgets and also setting up right alerts to it, right? It should not be something that you are monitoring at the end of the month and then making changes, versus it should be proactive in terms of real time monitoring, and where you get the alerts and you're fixing it in real time, right? It's a continuous process. It's not like one day you optimize everything and then you leave it and it remains same. It doesn't happen that way, right? And definitely basically ensuring whatever is over provision, you do the right sizing, and regularly auditing your cloud environment is really very important, is what I feel.
Perfect. So with that, we are ending our podcast. So thank you both of you for coming to my channel, and don't forget to ask everyone to like, subscribe, and share. Right. So that's an as a YouTuber, it's my duty to ask everyone. So thanks everyone for joining, and keep watching our channel. You're going to have many more guests and many more interesting topics. So thank you, Kiran and Abhishek, for being here. I really appreciate it.
Thanks a lot, Navneet, for inviting. Thank you so much. It was really interesting. Nice meeting you, Kiran, as well.
Likewise, thank you all, thank you both, and it was a great session. Thank you.
Yeah, bye.
Thanks, everyone. Bye bye.